think back to when we did kinematics with rotation at the beginning of the semester, if we have an object that's rotating, there are two components potentially to the acceleration of a point on that object that's rotating. There's a component that we used to say was in the theta direction, that's kind of perpendicular to the edge of the circle. Now we're going to call this the tangential acceleration. It's tangent to the edge of the circle. And then there's a second component that's usually in towards the center of rotation that's keeping it moving in a circle. And this was the radial acceleration before, and now we're going to call it the normal acceleration. And if we go back to those kinematic equations and assume that the radius is constant, which is reasonable in this case where we're talking about rigid bodies, so things aren't getting bigger or smaller, then we can say that the tangential acceleration is equal to alpha times r. It would have been theta double dot r in our original notation where we were just using theta. And the normal component of the acceleration will be minus, that's into the center of the circle, omega squared r. It used to be minus theta dot squared, and now instead of theta dots and theta double dots, we're just going to use omega and alpha for angular velocity and angular acceleration. And these pieces are really helpful because as we move into rigid bodies, things will start to be connected in the motion. Think about rolling a wheel along the ground, right? We have to know that there's some similar motion happening at the ground. And so being able to identify the components of this acceleration is really crucial for that. And so these equations are really helpful for identifying those pieces of motion.